Hello and welcome to this lecture on an overview of the minerals. The minerals are our second of the two micronutrients. We've studied vitamins, looking at both fat-soluble and water-soluble vitamins, and now we're looking at the second classification of micronutrients, which include the minerals. Now, whereas the vitamins were classified based on their solubility, the minerals are classified a little bit differently. And it's basically classification system based upon how much you need in your day by your diet. So the minerals are divided into what are called the major minerals or the trace minerals. The major minerals are those that require more than 100 milligrams per day by your diet, whereas the trace minerals are those that you need less than 100 milligrams per day. Major minerals are also present in the body in amounts of greater than 0.01% of your total body weight, and trace minerals are those that are present in your body in amounts of less than 0.01% of your body weight. You can see the major minerals that are listed here: sodium, potassium, chloride, calcium, phosphorus, magnesium, and sulfur. Now, it's not to say that if a mineral is listed as a major mineral that it's more important than a trace mineral, because of course you see under the trace minerals something very important, for example, like iron. The other trace minerals include things like copper, zinc, selenium, iodine, chromium, fluoride, manganese, molybdenum, and a few other minor minerals that we won't be studying in this course. As an overview, minerals are also referred to as elements, and that's important to keep in mind when you're looking at the DRI tables, because the DRI tables at the top, where there's the title of the table, it will describe the minerals as elements. So you won't see the word minerals, you'll see elements. There's tables, of course, for macronutrients, for vitamins, and then for elements, which means minerals. So minerals are elements that are needed by the body in small amounts for health and maintenance. Now, they're definitely important, even though you only need them in very small amounts or micro amounts. That's why they're part of the micronutrients. Minerals are available primarily in unprocessed foods. There's less mineral content in some processed foods, and then there's minerals, of course, in supplements as well. Now, one of the minerals that you find more of in processed foods than unprocessed foods, for example, is sodium. In order to maintain health, minerals must be consumed in their correct proportions, and that's part of what we'll learn about in this module. As was the case with vitamins, minerals also involve the concept of bioavailability. Bioavailability refers to your body's ability to get and utilize the mineral content from the foods that we eat. There are certain compounds in foods that we eat that decrease mineral bioavailability. For example, compounds such as phytates, which you find in whole grains, can limit your body's ability to absorb calcium, zinc, and iron. Now, you'll still absorb some calcium, zinc, and iron from, let's say, whole grain foods, but it's less than you might in another product that did not contain phytates. When we study the minerals, please keep a copy of the DRI tables close by, because the DRIs for minerals are based and are listed in the DRI tables. We're going to look primarily at the RDAs and the AIs. In this course, we don't look at the EARs. Remember, if there's not enough data to set an RDA, then the DRI committee has set an AI, or adequate intake level. Because certain minerals can be toxic if taken in too high of an amount, there are some minerals for which a UL, and that's the tolerable upper intake level, or upper level, have been established. When we learned about the B vitamins, we learned that the B vitamins function as a family as what are called coenzymes. Well, minerals have, together, collectively, a similar function, except instead of being a coenzyme, minerals are called cofactors. And minerals also serve as electrolytes. Here's an image that's explaining how minerals function as cofactors. In step 1, you see the mineral cofactor that combines with an incomplete enzyme to form an active enzyme. The active enzyme binds to the molecules in a chemical reaction. In this case, it involves compounds A and B, and accelerates their transformation into products A and B. The final product is released, and the enzyme stays unchanged. So, much like how the B vitamins function as coenzymes, the minerals function as cofactors to expedite or allow for enzymatic activity. Minerals, as I mentioned, function as electrolytes. Some of the electrolytes include sodium, potassium, and chloride. And the primary function of electrolytes are to help your body control your nerve impulse conductions. Electrolytes also play a role in maintaining the pH balance, so that's the acid-base balance in your body, and to prevent your body from going into acidosis or alkalosis. Here are the classification of the major and the trace minerals that we will cover in this course. The major minerals are sodium, potassium, chloride, calcium, phosphorus, magnesium, and sulfur. And the trace minerals that we will look at include iron, copper, zinc, selenium, fluoride, and iodine. This last slide is showing you the difference between the major and the trace minerals, and it's basically how much is required in your body per day. A pound is about 454 grams. So in your body, it's only calcium and phosphorus that appear in amounts larger than a pound. The rest of the minerals, even if they're major minerals, take up less than a pound of your total body weight, but yet you'll see they're very important even though they comprise only a very small amount of your total body weight.